Hello all. In last session we have seen about definition and results on trees and forest. Today we will see about rooted trees, subtrees, ordered rooted trees and M-ary tree. Let us quickly revise what is tree and forest. A tree is an undirected graph which is connected with no simple circuit, and forest is a disjoint union of it. Now let us start with the rooted trees. By the name itself you can imagine that in a tree there is only one and only one root, and all connected to it are called as its branches. So mathematically itself the definition is a tree in which one vertex can be defined as a root and all other vertices connected to it are directed from it is called a rooted tree. Let us see an example on this. This is an example for a rooted tree. Let us see one more example. If for this graph you can take any vertex as a root. So if I take A as a root, then I can draw this as the A's branches are 3, it is C, B, D. Then B has 2 branches, F and G. C has only one, E, and D doesn't have any branch. In the same way, if I start with C as a root, then C has 2 branches, A and E. A has 2 branches, B, D. B has 2 branches, F and G. You can see in this figure. Now you have heard about family tree. So in that you have parent, children, ancestors and descendants. Ancestors means parents and descendants means whose children are parent. So the same concept mathematically implemented here. If A is a root here for this graph, I can say that as a parent, and it must be unique. Now its children are B, F, G. B, F, G are called children. Then B's child is C. C's children are D and E. F doesn't have any children. G's children are H, I, J. H child is K. I doesn't have any child. J's children are L and M. So these are parent-child family tree, and you have to remember these words. And here B, F, G are the children of A, and they are called siblings for each other, and the vertices who have children are called internal vertices, and who don't have a child are called leaf. And for the final stage, all the upper vertices are called ancestors including root, and for the root, for the first stage, all the below vertices are called descendants. This is true for each and every stage. Let us see example on this. Before that, what is subtree? Subtree means a subgraph with any vertex as a root and its descendants. So for example, if I take G as a root and its all descendants, it is called a subtree. So let us quickly see the example on this. So this is a rooted tree. You can see directly there is one root and all other are its branches. So You have to find parent of C. Parent of C is B. Children of G. Children, parent means the upper vertex, children means the lower vertices. So children of G will be Hij. Then siblings of H other than H is Ij. All ancestors of E means all upper vertices of E are C, B, A. All descendants of B, all lower vertices of B are C, D, E. All internal vertices means vertices who have children are B, C, G, H and J. Here all other vertices are leaves who don't have children. So like F, D, E, K, I, L, M are leaves. Next question is what is the subtree rooted at G? So you know this by G you have to take this full subgraph with all the descendants and G as a root. I can draw subtree with root C also. This is the subtree with root C and so on. Next definition is an M-ary tree. So a rooted tree is called an M-ary tree if every internal vertex has no more than M children. So if I talk about 3-ary tree, then it's all internal vertices, or you can say all stages has maximum 3 children. That means it can has for 1, 2 or maximum 3 children. In the same way, next definition is full M-ary tree means exactly M children. That means a tree is called full M-ary tree if every internal vertex has exactly M children. So if I am talking about 3-ary, full 3-ary tree, then its all branches has exactly 3 children, 3 branches. And if M is equal to 2, then it is called a binary tree. You have to remember this definition. That means all internal vertices has exactly 2 branches. So let us say, let us check an example on this, that the given T1 to T4 are full M-ary or not, or M-ary or not. So for that T1, here the first vertex is root. You can see it has 2 branches. For the second stage, 2 branches. Third one, 2 branches. Each and every stage has exactly 2 branches. So it is called full binary tree. Now for the second example, this is the root, and you can see this has 3 children or 3 branches, and each internal vertices has exactly 3 branches. So it is full 3-ary tree. For T3, if I take this as root, you can see it has exactly 5 branches, 5 children, and each internal vertex has 5 children. So it is called 5 full array tree. And what about T4? If I this is the root and this root has 2 children, then its internal vertex has 3 branches and then 2 branches. So it is not a full M-ary tree. Next definition is an ordered rooted tree. So what is it? An ordered rooted tree is a rooted tree itself, first of all, where the children of each internal vertex are ordered. So if I can order, if I can name the internal vertices, then it is called an ordered rotatory. Let us see an example on this. For example, for this rotatory with root A has two branches and each internal vertex has two branches, so this is an full binary tree. So this binary tree, if I can say this left child B and E as right child, then the tree is called ordered rotatory, and the subtree with left child is called left subtree, and the subtree with right child is called right subtree. This is it for the today's session, and for the assignment part, you have to solve two examples. The first one is what are the left and right children's, and the so on. Next, which graphs are trees? Next, answer the following. Thank you.